And what is the structural formula of compound Q? Where is compound Q? There is compound Q. And let's have a look at that and mind what they are in need of, the structural formula. We don't just have to write anything, guys. We go by the rules. If you are asked to do that, make sure that you follow that. According to instructions, read them carefully. And here, compound Q, which is the major product, right? Look at this. Remember here, you had a haloalkane. When you say haloalkane, it is an alkane, but somewhere it has got a halogen. And you call that, again, an alkyl halide, right? And in this case, you find that when you've got this and you are using, this is the main part, concentrated base. Concentrated and again strong base to add to that. It's concentrated, it is strong. And if that is the case, if you do have that particular type of reaction, ultimately you've got to come up with a compound that will somehow have a double bond. And from single bonds to a double bond, it means some of the things have to be taken out. And when you take out some other atoms here, what are you doing? You are eliminating, isn't it? So in this case, in the where we use concentrated strong base, you are going to form an alkene. So it will definitely go according to the number of carbon atoms that you already have. You cannot form an alkene with fewer carbon atoms. And can you see I've put that double bond there because I'm still led by where we have this double bond. The OH. Okay, so I can even put it here definitely because the second carbon atom, not the first one. The first one is there, but the OH is on the second. Right, now what is it that we are going to have? We are going to write the structural formula here. So let us write that. So we have that, 1, 2, 3, 4. 1, 2, 3. So this is the only one that is left. You can put it down or upward there, that is not a problem. And then 1, 2, 3, we still need something. And then 1, 2, 3, 4. Right, and then there's something else that is very important here. When you take out the Cl, let me just complete this diagram here. We have that, that, as well as that. So these hydrogens are still there. Now when you come to a double bond, it means you took out the Cl, because this Cl is going to react with this sodium here and you form sodium chloride. But we are not talking about substitution. It doesn't mean that now something has to come for that. No, Cl will go, and at the same time even the H will go. So we now have, double bond. And when we have that double bond, but now the H that will go will not necessarily be the one that is coming from the same carbon atom. Okay, so if another H goes, then we are going to have a double bond here. So this is going to run short of hydrogen. This is going to run short of chlorine. So we are going to have a bond there, a bond there, and therefore you are going to have a double bond there. So it's between the first and the second. So I got it correctly the first time. It must be there. Okay, it must not be there. This is where it was. So it is there, it is there. So we can have this, and then we have that. Okay, guys. So this is what we have. Right, so 1, 2, 3. 1, 2, 3, 4. 1, 2. Can you see? I can't have another one. Otherwise, we're going to have 5 of them. 1, 2, 3, 4. 1, 2, 3, 4. So I don't have this one as well. Okay. So there you go. There you go. There you go. There you go. So while you are asked the structural formula, the main thing that the examiner wants to see is to check where you are going to put the double bond. And again, how many hydrogen atoms will you really put there?